in terms of key ideas that we wanted to cover, one of the first is that we still think about the internet as a nice to have. And by that, I don't mean that we do individually think that way, but as a society and from a policy point of view, we're not at the point where we're treating connectivity the way we treat and think about water, sewer, and electricity. COVID probably has really moved the dial on this, where so many of us are working from home or doing school from home and doing myriad other things. Today's a significant day in the country because legislation was introduced into the House of Representatives for a $100 billion, that's with a B, internet access bill at the federal level. And we don't know whether this will be passed or not, but it is an acknowledgement from the federal government that we need to be more serious about broadband. And that's really what the Fairhaven town leaders have been really foreshadowing, is that this is important for the community and we need to be real deliberate in the way we think about this. So a question for all of you and for your neighbors is whether broadband is now at the level that we need to treat the infrastructure like utility infrastructure. Is it still a nice to have, or in reality with the digital economy, is this infrastructure essential infrastructure? So one way to think about it is it the fourth utility? Another category that's important to understand is what technologies are available today and what can these technologies do. DSL is the technology that primarily the telephone companies have utilized. So when the internet emerged, the cable companies and the telephone companies saw it both as a threat and as an opportunity, and they quickly figured out, and they were working on it. The telephone companies were involved in the emergence of the internet. But they quickly figured out how to run this technology over their existing infrastructure. And some of that infrastructure was DSL. So DSL has been widely used by the phone companies. Its upper limit is really 100 megabits. If you're on DSL, so Verizon would be the DSL provider in Fairhaven. If you're on DSL, you may not see 100 megabits. That's the download speed. The upload speeds will be significantly lower, but that's sort of an optimistic threshold for DSL. A lot of people are talking about Starlink and low orbit satellites currently. So Starlink is Elon Musk's satellite company. There are other satellite technologies. There's HughesNet and various others. The people I'm talking to that are on this technology now are seeing 100, 110 on the download speed and around 10 on the upload. Price point is 99. What they're paying is 105, 106 bucks a month for something a little better than DSL. So that technology is out there. It's not going to, it really is targeting people in very rural areas. It in no way can compete with fiber in terms of its capacity, and it's not meant to compete with fiber. It's really for people that live miles and miles away from fiber optic networks. The other is cable, and the majority of people in Fairhaven are on a cable system. Sort of the upper end, the optimistic end of cable capability is a gig, which is 1,000 megabits per second. And and then the download, again, as Stephanie alluded to, is much lower than that. It's asymmetrical in nature, which means different upload than download speed. And then there's 5G, which there's a lot of advertising about. 5G is really the next generation of cellular networks. And you know, 2 gigs is probably quite optimistic for 5G, but that's what the industry is touting, is that it'll have that capacity. I think actual experience might be closer to 1 gigabit, but we'll go with the industry numbers. The reality for 5G is that it doesn't work without fiber. So we say with wireless that wireless works best the faster it gets to fiber. And depending on which flavor of 5G people are talking about, if it's the nanocells, then you've got to have fiber in really close proximity, like every 1,500 feet. So the microcells require this dense fiber network, which is very close to fiber to the home. It's very close to the same sort of density of fiber. And then the other technology is fiber optics. And this graphic is meant to illustrate the difference in capacity between DSL, low orbit satellite, cable, and 5G. So this is not unrealistic. This is not a pie in the sky. Fiber actually can do, they demonstrated fiber at 170 million megabits per second. So we're showing 25 million megabits per second. There are tests of sending a signal 1,000 kilometers at 170 million megabits per second, and which means that we haven't hit the upper threshold of fiber capacity. And the limits of fiber are really, the limits aren't in the fiber itself, the limits are in the electronics that connect to the fiber. And the electronics will get better and better over time. And they're figuring out how to utilize fiber to offer more capacity. So when you think about the reality that most people today in Fairhaven have less than, let's say less than 500 megabits per second, I think that's safe to say. And that the capacity of fiber is in the millions of megabits per second. Hopefully it's clear that when we say this is a future-proof technology, it is future-proof, meaning it's 50-year technology. Even if they come up with something that's better than fiber, it's hard to imagine a scenario where we're going to need something more than 25 million megabits per second. Those speeds are just sort of mind-blowing, actually. Another key thing is that for 99% of the networks in the country today, whether they're cable, most implementations of fiber or DSL, they're using some kind of splitter technology. And what that means, what really is happening is that most homes are sharing with their neighbors. And the usual splits are either at 32 or 64, which means most people are sharing their connection with either 31 neighbors or 63 neighbors. And that affects reliability. So when these companies tell you that your speeds will be up to something, what they mean by that is they can't really tell you what your speed's going to be because your speeds are impacted by all of your neighbors. And that's a key thing, because 99% of the networks in the country are architected or designed this way. You either need a really fast network so that you're not noticing what your neighbors are doing, or you need a different kind of network. And what we've encouraged the committee is to think about a switched network where everybody has a direct connection into a switch. And what that means is everybody's on their own network, so that your neighbors are not affecting your reliability. And these switches have been around. This is the way data centers are designed. The world that's emerging is a world where we're going to need reliability, because everything's going to get connected to this network. And by everything, what we mean is there's a trend toward hospital at home, which means a lot more healthcare is going to happen in the home, which means devices like IV pumps are going to be in the home. We already know that education is happening across these networks. People are working on doing their work at home across these networks, but we're also, there's a lot of emerging technology which will be sensor informed and AI impacted, and the network reliability is going to become an increasingly important issue. We also referred to this. I would say again that 99% of the networks in the country are asymmetrical, which means the download speed is much better than the upload speed. And with fiber, there really is no reason to have an asymmetrical network. Fiber networks should be designed to be symmetrical so that people have abundant bandwidth on both the download and the upload. And so that's another key thing that we're looking for in terms of a different kind of network. We want it to be not shared with neighbors. We want it to be fiber, and we want it to be symmetrical. Another key idea that we've spent a lot of time on is with the committee is this idea of separating the infrastructure and the services. The history for telecom and cable is that these things have been commingled, and that services really are synonymous with whoever controls the infrastructure. So I would bet that everybody on this call has the same ISP as they have for the owner of the infrastructure. So if you're on a cable network, whoever owns that cable network is also going to be your ISP. What we've talked about is creating an infrastructure operator, and we have a deep belief in local ownership of infrastructure because the infrastructure is locally important. So if you have local control and ownership of infrastructure, and you've got a local company operating that infrastructure, what we advocate is to push services to the cloud. And by that, we also mean the internet service provider. So part of what we advocate for is ISPs in the cloud, which allows for competition. It gives consumers choice. It also exposes the ISP to innovation, which means a competing ISP may figure out how to automate, to deliver better customer service, more responsive information to customers, et cetera. So that all becomes possible once you move the ISP to the cloud and you create this separation between the infrastructure and service. So the metaphor that we use a lot as a company is this metaphor, which is we need to run our digital roads the same way we run our physical roads. So the way cable companies and the legacy phone companies run their networks, they build their own digital road, connect it to the big internet, and nobody else operates on that road. And the analogy for the physical roads is that it would be akin to giving FedEx their own road and giving UPS their own road. That doesn't make sense, and we don't think it makes sense anymore to have one road for the cable company, another road for the telephone company, and then have some overbuilder come in and create a third road. So we advocate for one really robust road that's open and allows any service category and any service provider, as long as they follow the rules, as long as they're not doing things malicious, let anybody operate on that road. And we run our airports this way, we run our road systems, and now we're saying we should run our digital infrastructure the same way. So this is just an example of how this can work. So when the service providers moved to the cloud, this is the kind of interaction that consumers can have. So you would go in, look at your options for ISP, look at the pricing, and once you find the ISP that you want to utilize, there's some legal stuff. And then when you hit subscribe, because they're in the cloud, software can create the connection. So we go up to the dashboard and we now have an ISP. If you decide you want to switch ISPs, you just unsubscribe and the connection is broken down, and you can go back out and select a new internet service provider. So this is called open access. And by open access, it means it's open to any service provider. And this is one instantiation of what that looks like.